What's up, guys? This is Mr. O'Brien. This is going to be part two lecture of reactions and equations solely for the honors classes. Now, if you're in college prep, you have to go back to part one lecture of equations and reactions. This information for the honors students will be found in section 10.2. So let's go ahead and get started. So the question is, are all chemical reactions the same? Well, let me go ahead and start by saying or asking if all books are the same. Here we have an autobiography, a cookbook, a fiction, and nonfiction book. Now, they're clearly not the same. And why do we have all these different types of books and various types of the same type of book? Well, because we have a plethora of information that can be gathered from these books, and we can organize this information in libraries based on the categories of those books. Now, we can have some rules organizing chemical reactions. Chemical reactions can give us a lot of information, especially on how products are created. So there's 5 basic chemical reactions. There are many more chemical reactions in the field of chemistry, but 5 basic ones that you should just kind of get a hold of. Synthesis, decomposition, single replacement, sometimes called single displacement, double displacement or double replacement, and then a combustion reaction. All of these have a different way that the reactants combine and rearrange with each other to create products. But there's a pattern that we can recognize, and that's the idea that we're going to try to tackle today. So let's get started. So chemical reaction number 1, synthesis. So in a synthesis reaction, we have 2 or more reactants producing a single product. And in this case here, we have hydrogen gas being produced, reacting with chlorine gas. Now these reactants are going to rearrange themselves to create one new product. Now, the types of synthesis reactions don't necessarily need to be elemental like this one here. It can be an element with a compound or 2 compounds. The main idea is that you have 2 or more reactants combining to make one new type of product, right? So let's take a stab at this and see if we can write a chemical reaction of a synthesis. So aluminum solid, AlS, and oxygen gas, O2G, react to produce aluminum oxide. So aluminum oxide, remember aluminum is a +3 charge and oxide is a -2 charge. It would be Al2O3. And initially looking at this, we might see that, hey, we can put 2 aluminums here and there's 2 aluminums there. But the problem is we can't get that 3 to balance out with an even oxygen atom. So let's make this a 2, make that a 4 now. And now we can go ahead and make this oxygen a 6 by adding a 3. So here we go, 2 reactants combine together to form 1. Let's take another example. Decomposition. In decomposition reaction, we have a single reactant in this case, breaking down into 2 more products. It's the opposite of a synthesis reaction, if you can see. Common example of a decomposition reaction, which is an important reaction that happens in automobile airbags. There's a canister inside of your steering column or maybe your dashboard that contains a canister of solid sodium azide. When an electrical impulse is reached to this canister, this solid is decomposed. The bonds between these atoms break up and rapidly form sodium solid and nitrogen gas. It's this nitrogen gas that forms that causes the inflation of the bags. And it happens at a really quick rate, right? So let's take a stab at writing a decomposition reaction. So aluminum oxide, so AlO, and we'll write a 2 and a 3, because remember aluminum is +3 and oxygen is -2, decomposes, arrow sign, when electricity is passed through it. So what does it decompose into? Well, let's figure out what we got. Well, we have aluminum, so why can't it break down into aluminum solid? We have oxygen. Well, why can't it break down into oxygen gas? Now remember, we can't leave O by itself, right? Because there's no such thing as oxygen by itself. In reality, it's oxygen gas as O2 as a molecule. So we have to now kind of fix this to make it law of conservation. So if you recognize this, this is kind of like the reverse of the last one we talked about. So we put a 2 here. This would be a 4. And then we can make this a 3. So 6 oxygens, 4 aluminums. The next type of reaction is called a combustion reaction. One most common to chemistry students when they use the Bunsen burner, or whenever they ask about, oh, are we going to blow stuff up? Combustion, right? And combustion reaction, what's important to recognize is that it requires the oxygen gas, oxygen molecules, and it combines with other reactants to form certain products. In this case here, you can take a look at all the oxygen gases are as your reactants. In this case, when hydrogen gas it combusts with oxygen gas, it creates water. When carbon and coal reacts with oxygen gas in combustion, it creates carbon dioxide. And the most important one that you need to know, right, is what happens when a hydrocarbon combusts. And a hydrocarbon, if you recall from your book Napoleon's Buttons, let me write this down, a hydrocarbon is any molecule that contains both hydrogen and carbon. So we call this a hydrocarbon. And there's various types of hydrocarbons. But when you combust a hydrocarbon, you're going to get both water and carbon dioxide as your products. And those are the only products that you get. So it's kind of easy to memorize when you have a combustion of a hydrocarbon. It's these two products that you make. Now, the only challenge will be is to recognize the balanced chemical equations, because these coefficients might always be 1 to 2, depending on what the hydrocarbon is, right? So let's practice some combustion reactions with hydrocarbons. So here's ethane gas. So ethane gas, C2H6, burns in the air. And so when it burns in the air, it's burning with oxygen gas. And that oxygen gas with the ethane will produce carbon dioxide and water. Notice that I don't need to tell you that we have to have water and carbon dioxide. You should know that based on just a hydrocarbon with oxygen, right? So now in this case, we got to balance our chemical equation. So if I put a 2 here, right, that's 2 carbons. And if I put a 3 here, that'll be 6 hydrogens. But 3 oxygens and 4 oxygens here, 7 oxygens will not in anywhere be even to the even number here. So a 1 won't work. So if we put a 2 here, this will be 4 carbons. Get rid of this guy and put a 4 there. And get rid of this guy and put a 6 there. Now we have 12 hydrogens, 4 carbons, 4 carbons. And now 4 times 2 is 8. 8 oxygens plus 6 times 1 is 6, which gives us a total of 14 oxygens. If we place a 7 here, that will give us 14 oxygens. All right, let's jump on to the next chemical reaction. The next chemical reaction is called a single replacement or displacement reaction. So this is an important one which you have to memorize in terms of understanding what the products form. In a single replacement reaction, one element replaces an atom of another element in a compound. Keyword here, element to a compound. Now, you can also consider it that metals will always replace cations, including hydrogen, because it's considered a cation, or non-metals will replace anions. Remember the negative charges, right? So if you look at these examples here, the lithium, which is a cation, will replace the hydrogen. And so when it does that, the hydrogen will be by itself as H2, and then the lithium will combine with hydroxide. Now remember that water, it can also be written as HOH. So you can see the plus from the hydrogen and the minus from the OH, right? In this example here, the metal, the cation, is going to be swapped with another metal, right? And so now the silver is by itself, and this copper will now be paired up with nitrate, right? Now, in this example here, the non-metal fluorine is going to be swapping out with the bromine of sodium bromide. And so you have bromine liquid by itself, and then sodium fluoride has a partnership. So there's other examples like we've done in class of the example of the silver and copper replacement, right? Which we have copper metal in a silver nitrate solution, and that copper silver nitrate will replace the silver So you have these silver particles kind of coming off of it, right? We'll see how we can write a single replacement reaction. Now, in this case here, you're going to have to predict the products, right? So we know that K is a +1, and Zn in this case is going to be a +2. Now, how do we know it's a +2? Well, we know it's a +2 because you only have one Zn, and we know that the chlorines are -1 always, but yet we have two of them. It's really important if you want to remember anything on how to predict, you got to recognize first the ions. You got to recognize the ions and their charges because they're going to be swapping. In this case, the K is going to be swapping out with the zinc. So the zinc is going to be by itself, and now the K is going to hook up with the chlorine. Now notice that I write K with chlorine, but I don't write the 2 there because that 2 has to be the formula for this guy, and the formula for KCl might be different. Let's write the formula for KCl. K is a +1, Cl is a -1 from your periodic table. This is a okay formula. The ratio is +1 -1. It's neutralized. And so we don't need to do anything to this formula. What we now need to do is we now need to balance this equation. So if I see 2 chlorines, and I only see 1 chlorine here, I'll put a 2 there. 2 Ks now versus 1 K, I got to put a 2 there now. So now I have a 2K plus zinc chloride produces 1 zinc and 2 potassium chlorides. And there's your chemical reaction. Again, you got to be able to recognize the ions. That's the first step to do these problems. Well, let's try another problem. And this is a double displacement reaction, right? In this case, atoms of a compound is going to replace atoms of another compound. And hence it's called a double replacement because now we're talking about both of them are compounds. But the process remains the same. Metals, including hydrogen, will replace cations. Remember, these are the plus ions. And nonmetals are going to replace the anions. In many cases, these kind of reactions produce precipitates, which you've probably seen in class, in which 2 liquid solutions, or in this case, aqueous solutions, combine together to form a solid precipitate, which is this yellow. Let's look at some examples that you can see here. So in this first one, the silver are going to be these ones here, and the these large ones here is going to be your cation, your potassium. So this is going to be the K, and this is going to be your Ag. Now notice the Ag and the Cl combine together, and the K, which is right here, and the nitrate also combine together. They just essentially swapped. In this case, the K is going to, the Ca is going to swap with the H to have CaCl. And the H is going to hook up with the OH to create H2O. Or if you recall, it's also HOH. In this case, the sodium is going to swap with the copper. And that copper is now going to hook up with hydroxide, CuOH. And the Na is going to hook up with a Cl to find NaCl. Okay? Well, let's try these double displacement reactions. Remember, the first step is recognize the ions. You got to be able to recognize the ions first. So let's go ahead and try to recognize these ions. So this is a Ba +2, and this is a Cl -1. Okay, we know that from the periodic table. This is a K +1 periodic table. And this CO3, although if you don't see the the polyatomic ion sheet, you can recognize that you only have one CO3, this carbonate. And that carbonate is probably going to be a -2 charge. How do I know that? Because you need 2 Ks. And so the carbonate is going to be a CO3 -2. So now remember, the metals swap with the metals. So these two swap out. So now the K is going to hook up with the Cl, and the Ba, the barium, is going to hook up with a carbonate. Now let's write the formula for these, right? Well, the formula here is untouched, right? It's just KCl, right? The formula here is untouched as well. This is going to be barium carbonate. Now, why are they untouched? Because, again, the charges are canceling each other out. We don't need to carry these subscripts over because they are unique. These subscripts are unique to these combination of ions. Now, we need to balance this chemical equation, right? Because I see 2 potassiums and I see 2 chlorines. So if I put a 2 here, that gets me 2 Ks and 2 Cls, and I have 2 Ks and 2 Cls. And there is my balance equation. 1, 1, 2, 1. Try these problems out for predicting chemical products from chemical reactions or identifying types of chemical reactions. And if you have a hard time, hit me up at tutorial. Thanks.